Welcome to the Explainer. So, let's talk about one of the biggest questions in the digital world. How does a network with no boss, no central bank, nobody in charge, how does it agree on what's true? Well, it all comes down to this really cool process called mining.
Okay, so let's start with the problem that started it all, the one Satoshi Nakamoto was obsessed with solving. Think about it. If your money is just a digital file, what's to stop you from just copying and pasting it? Spending the same coin over and over.
And hey, this isn't just some brain teaser. It's the real challenge that made digital cash so tricky for so long. There's a name for it, the double spending problem. And solving it, that's exactly why blockchain mining was invented.
Yeah, our source material makes a great point here. This is a problem that's pretty much unique to digital stuff. I mean, if you could actually spend the same digital dollar twice, the whole system would just fall apart. Trust would be gone, the currency would be worthless because the network would be flooded with fake, copied money.
So the big question is, how do you solve this without a bank, without some central authority checking every single transaction? The answer is, well, it's pretty brilliant. It's this global network of competitive validators, and we call them miners.
All right, so let's get into how this whole thing actually builds a secure ledger. And just to be clear, when we say mining, don't picture pickaxes and caves. Seriously, it's nothing like that. A better way to think about it is like this. Miners are like thousands of hyper-competitive accountants all around the world, all racing to be the one who gets to update the books. So what are they actually doing? Well, in a nutshell, they're in a constant high-stakes race. They grab a bunch of new transactions, bundle them into what we call a block, and then they all compete to solve this really hard math problem. The first one to crack it wins. And the prize? They get to add their block to the official chain. Okay, but why would anyone bother? Why spend all that time and electricity? Well, this is where the genius of the incentive structure comes in. The winner doesn't just get bragging rights, they get a reward of brand new coins plus all the transaction fees from that block they just added. So this reward system, it's literally what pays for the security of the whole network. Now, the most famous method for this is called proof of work. It's the engine that powers Bitcoin. You can really think of it as a brute force race, a massive digital lottery to find one specific winning number. So let's break down how it actually works. Okay, here's the play-by-play. First, a miner grabs all the new transactions. Then, they add the digital fingerprint, the hash, of the last block, which links the chain together. Then comes the guessing game. They start guessing a random number, it's called a nonce. They mash all this data together, run it through a special math function to get a new hash, and then they check. Does this new hash meet the network's target? Usually that means, does it start with a whole bunch of zeros? If not, no problem. They just change the nonce by more a little bit and do it all over again. And again, and again, millions of times a second. And when I say millions of times a second, I'm not exaggerating. The scale here is just mind-boggling. Our source material points out that even a modest miner can crank out 100 million of these guesses, these hashes, every single second. That's the sheer brute force that's securing the network. And this really gets to the core idea. There's a quote from our source material that just nails it, explaining the genius behind proof of work. And here it is, the key principle, asymmetric effort. Think about it like this. It might take a gazillion guesses from computers all over the world, burning tons of energy for, say, 10 minutes just to find that one winning number. But the second it's found, every other computer on the network can look at it and go, yep, that's the one, almost instantly. It just takes them one single calculation to check. So it's super hard to find the answer, but incredibly easy for everyone to verify it's correct. But as you can probably guess, all that computational work uses a ton of energy. And that's led a lot of smart people to ask, is there a better way? So let's look at some of the alternatives that have popped up. Many of them try to trade that raw computing power for something else, like economic incentives. So here we can see a few of the big ones compared. Take proof of stake. Instead of proving you've done a bunch of computational work, you prove you have skin in the game. Validators have to lock up or stake their own coins as collateral. If they try to cheat, poof, the network can take away or slash their stake. It's a huge financial reason to play by the rules. Then you've got something like proof of burn, where you literally destroy coins to earn the right to mine. It's a way of proving you're committed. See the pattern? Both of these replace the raw energy of computation with a direct financial commitment.
Now, the really important thing to get here is that there's no single best way to do this. Every single method is a trade-off. A project that wants the most hardcore, battle-tested security might say, we're sticking with proof of work. But another one that's all about speed and being green might go for proof of stake. It all depends on what you value most.
And in this choice, it really gets down to the philosophy of the network itself. What's the best way to guarantee security? Is it through raw, brute force computing power, where basically anyone with a fast enough computer can jump in and compete? Or is it through economic incentives, where the people with the most to lose are the ones in charge of keeping things safe?
And that kind of leaves us with this huge question for the future, right? As we build more and more of our digital lives on these decentralized systems, how are we going to agree on what's true? Will it be secured by sheer computational muscle or by clever, sophisticated economic games? Whichever way we go, the choice is going to define the very foundation of the next version of the internet.